Hello students, what is going on? My name is Abdullah Momin from KMES English Medium High School and Junior College, and this is your lecture number 10 from a chapter Sound of class 11 Physics. And in this video we are going to see the numericals of this chapter. So the very first exercise which is given in your textbook is example 8.1. And the question is, the speed of sound in air is 330 meter per second, and that in glass is 4500 meter per second. What is the ratio of the wavelength of the sound of a given frequency in the two media? So here what is given, the speed of sound in air, we can write it as V air. Speed of sound is denoted by V, and in air it is 330 meter per second, and the speed of sound in glass is 4500 meter per second. So we will write it as V glass. So speed of sound in glass is equal to 4500 meter per second. So V air and V glass is given, and we are supposed to find out the ratio of wavelength of sound of a given frequency. We are supposed to find out the wavelength of air divided by wavelength lambda of glass. So V air is 330 and V glass is 4500. We are supposed to find out the ratio of their wavelength. Means we are supposed to find out lambda air upon lambda glass. So we know that the formula of speed of sound is equal to V is equal to N lambda, and for air it can be written as V air is equal to N lambda air, and for glass V glass is equal to N lambda glass. When sound enters from one medium to another medium, and in this case air to glass, the frequency of sound does not change, it will remains constant, but wavelength changes. That's why the speed is changes. So we are going to divide this equation, and n will get cancelled, and we will get lambda air upon lambda glass is equal to V air upon V glass. And V air, we have the value 330 divided by 4500, and when you will solve this you will get 7.33 into 10 raised to minus 2, or we will write 0.0733. So this is the ratio of wavelength of sound of a given frequency in the two media. Now next question, that is 8.2, example 8.2. Suppose you are listening to an outdoor live concert sitting at a distance of 150 meter from the speaker. Your friend is listening to the live broadcast of the concert in another country, and the radio signal has to travel 3000 kilometers to reach him. Who will hear the music first, and what will be the time difference between the two? Velocity of light is 3 into 10 raised to 8 meter per second, and that of sound, means velocity of sound, is 330 meter per second. So first, who is going to listen the sound first? So you are sitting at a distance of 150 meter from the speaker, and the sound is traveling from speaker to your ear, and it has to travel the distance. So distance upon speed is nothing but time. We know that speed v is equal to distance upon time. So instead of v we can write t, and instead of t we can write v. So time taken by the sound to reach from speaker to you is t1, and it can be written as distance upon velocity. So while sound is traveling from a speaker, it is covering a distance of 150 meter, and it is moving with the velocity of 330 meter per second. So we will divide 150 by 330 and we will get 0.4546. This is the value of time taken by the sound to reach from speaker to your ear. But now this live concert is also broadcasted, and your friend is listening to this broadcast in another country, and the distance is 3000 kilometer. And while it is live broadcast, so this sound will travel at a speed of 3 into 10 raised to 8 meter per second, because this sound wave is carried by the electromagnetic wave. So the time taken by the broadcasted sound is t is equal to distance upon velocity. So we can write 3000 kilometer divided by 3 into 10 raised to 5 kilometer per second. So after solving this, we will get 10 raised to minus 2 second. That means 0.01 second. So the time has taken by the wave to reach from live concert to television set is 0.1 second. So this time is very small as compared to your time. So your friend will listen the sound first, and the time difference will be 0.4446 second. We will subtract this. Next, example 8.3. Consider a closed box of rigid wall so that the density of air inside it is constant. On heating, the pressure of this enclosed air is increased from P naught to P. It is now observed that the sound travels 1.5 times faster than at a pressure P naught. Calculate P upon P naught. So initially the pressure was P. After heating it, the pressure increases from P naught to P. Initial pressure is P naught, and after heating the pressure becomes P. So we are supposed to calculate P upon P naught. Pressure increases. So we have the formula: velocity of sound is equal to gamma P naught upon rho density, where gamma is the ratio of specific heat capacities, P naught is the initial pressure, rho is the density. VPO, this naught is not here. So Vp naught is equal to gamma P naught density. Density will remain same, but pressure has changes. And we know that Vp is equal to 1.5 times Vp naught, means pressure has been increases. Velocity has been increases. So we can write velocity at pressure P is equal to 1.5 times velocity at pressure P naught. So dividing these two equation, rho get cancelled, density will get cancelled. And now we will get the equation as, so what we have done here, instead of Vp, we will put this equation, and instead of Vp naught, we will put this equation. So gamma cancel, rho get cancel, squaring on both the sides, P is equal to 1.5. The square of 1.5 is 2.25 P naught. So P naught comes, we are supposed to find out the ratio of P by P naught. So P by P naught is equal to 2.25. P naught comes to another side and it gets divided with P. So P by P naught is 2.25. This is your answer. So next numerical example 8.4. A man shouts loudly close to a high wall. He hears an echo. If the man is at 40 meters from the wall, how long after the shout will the echo be heard? Speed of sound in air is 330. So distance traveled by the sound wave. Suppose a man is standing here and there is a wall in front of him and the distance is 40 meter. So when he will shout, the sound first travel a 40-meter distance, get reflected back from this wall, and again the sound will travel 40 meters. So the total distance covered is 80 meters. So the distance traveled by the sound wave twice the distance from the man to wall, that is 80 meter. Now suppose he shouts at time t0. So how much time has been taken to cover a distance of 80 meter by the sound wave? So we know that t time is equal to distance upon speed. So we are going to use this formula. So time taken to travel the distance of 80 meter. This is the formula of t, that is distance upon speed, 80.24 seconds. So when you will calculate this 80 upon 330, you will get 0.24 seconds. So the man will hear the echo 0.2 second after he shouts. So that's it, student. I will catch you next time.